Hello and welcome to Algebra 1, Chapter 3.2, and today we're discussing representing functions. So what is a function? A function is a relation in which each element in the domain is paired with exactly one element in the range. So remember from 3.1, a relation is a set of ordered pairs. And so your domain is your x values and your range is your y values. So one way of saying this is that every x has just one y. Okay, so if we look here, when you read tables like this, it's always x, y, so pressure and temperature. So the temperature would depend on the pressure. So every time the pressure is 1013 is the temperature 3. Every time the pressure is 1006 is the temperature 4. Well, so right there, if we can match colored numbers here. No, there we go. So it would be a function if this time when it was 1006, the temperature was 4, and this time that it was 1006, the temperature was 4. But that's not true. And not true for the 995. So if every x just has one y, then it's a function. But here we have several x's that have multiple y's. That is not a function. All right, so you can determine a function from any sort of visuals. Here, our first one, we have a mapping. So does every x map to one y? Negative 4 maps to just one y. Negative 1 maps to just one y. 1 maps to one y. 3 maps to one y. So yes, that one is a function. Let's look at the table next to it. Does every x map to one y? Yep, okay. The other thing is you're looking for repeater x's. So if you're in a table, you're looking for repeater x's, like right here, 2 and 2. It would be a function if they mapped each to the same y, but here 2 maps to 5, 2 maps to 4. That is not a function. Okay. And from our next mapping, does every x map to one y? Yep. Okay. Just so you know, from a mapping, and not a function would look something like 1x was mapping to two different y's. You'd have two arrows coming off 1x. If you have a graph, one way that you can tell whether it's a function or not is by the vertical line test. So vertical line test is that no vertical line can be drawn that intersects the graph more than once. So for this first one here is a function, because if I draw vertical lines, they're each just going to pass through that graph once. The second one, though, is not a function, because if I draw even just one vertical line right there, it's going to pass through the graph twice, so that's not a function. This third one is a function. You know, over here we're on the left and we're on the right. Well, so what happens if we're on the y-axis? Well, notice that top circle is an open circle. That means it's not actually a point, it's just a boundary. So yes, that's a function, and it really has to do with the fact that you have a closed circle on the bottom there and an open circle on top. So is x equal negative to a function? Well, sometimes these are hard, you might not know, well, is this a function or not? Well, let's graph it. And this graph is a little odd, so we want to make sure we do this one. So when x is negative 2, so what does that tell you x has to be? X has to be negative 2. Well, then what's y? Well, there's not a y in the equation, so let's say y is 0. Well, we need a few more points. Well, negative 2, well, maybe y is 1. Negative 2, y is 2. So if we graph these points, there's negative 2, 0, negative 2, 1, negative 2, 2. This is a line, and it is this line right here. It's the line where every single x is negative 2. Is that a function? That's not a function. It doesn't pass the vertical line test. Why don't you see there, I left you another one. It has an x and a y in it. Why don't you see if you can do that one on your own? The next thing we need to talk about are function values. Function notation is the first thing. So equations that are functions can be written in function notation. What that means is you're going to replace the y with an f of x. Okay, this tells me it's a function with respect to x, that x is my variable, and notice that on the other side we have an x. Okay, x is the independent quantity, okay, or the domain, right? f of x then becomes the dependent or the range. It becomes the y. They really mean the same thing, y and f of x. It's just that if it's written f of x, it is telling you it's a function. There's no question about it. Okay? So if you have something written f of x, what we can do is we can evaluate. So for instance, if I want to evaluate f of 5, that is the element in the range. So that this is a y value that corresponds to 5 in the domain. So if x is 5, what is the y value? And if we look up here, let's put in a 5 for x. It's going to be 15 minus 7. F of 5, 15 minus 8 is 7. F of 5 is 7. That corresponds to the point 5, 7, because 5 was our element in our domain. F of 5 is our element in our range. So with function notation, we can evaluate these. So f of 4, what this is we replaced x with a 4. So what's what we're going to do? We're going to replace x with a 4, and you are just working out the right-hand side. So that's 12 minus 4, which is 8, and you're done. Okay, the next one, we're going to replace x with negative 5. So negative 5 there. Okay, just working out the right-hand side, negative 15 minus 4 is negative 19, and we're done. Okay, these are the same thing where before maybe you were asked find y when x is 6 or something like that, and you put in 6 for x and you solve for y. These are the exact same thing with just a little bit different notation. So this last one is a little bit trickier. 5 minus f of 1. Well, f of 1 is going to be a number, and you probably should find that first. F of 1 is going to be 3 times 1 minus 4. 3 minus 4 is negative 1. We're going to be really careful here with our negatives, so we're going to put that one in parentheses because it is minus f of 1. Okay, which is 5 plus 1, which is 6. Alright, so that's the start of our functions. The main thing about functions is you need to remember that every x has only one y value. Alright, let me know if you have any questions, and have a great day.